undergrad students, graduate students? Where are you, and how are you placed right now? Anyone? Sri Lakshmi?
Yes, ma'am. Pardon?
Are you a student? Um, are you in? What are you studying if you're a student?
Okay, I'm a BSc Computer Science graduate. I'm hoping to do a PG in artificial intelligence if I get admission or any other
Okay,
PG.
all right. Anyone else?
We have a couple of comments in the chat section.
Ah, I didn't notice that. Let me check. Okay. Oh, wonderful. Okay. Game design. Is that a course actually? That's wonderful. Manmita.
Yeah, it's
There are,
exciting the kind of courses that are there out there these days.
yes, yes,
AI itself is such a new field, and of course, there have been game design and many such specializations, right? So
yes,
that's exciting.
yes. So Manmita, where are you studying? Which college?
Hi, I'm currently studying in Shrishti, and I'm also doing an exchange program right now with
Oh,
the Utrecht University in the Netherlands.
okay,
So, yeah.
okay. Yeah, so my son studies in Srishti too.
Oh, that's really
Yeah,
nice.
yeah.
So I see a few, joiners have computer science backgrounds, and
Mm,
that's nice to know. It's artificial intelligence and computer science are very adjacent.
mm.
Uh, I'm sure that there's going to be some great value that they'll get out of this.
I'm actually looking forward to the discussion with all of them, because that's going to be
Absolutely.
my value. I'm really looking forward to it.
Yeah, I look forward to that too. It should be fantastic. There's so many young folks, they're observing the same world through different lenses, and it's going to be fantastic to see what everybody thinks.
Yeah. And they have so much by way of opportunity right now, right? Sometimes I kind of feel a bit jealous, Rajesh.
Tell me about it. I mean, I've seen technology change a lot, but not a lot was given to us, I suppose, 20, 30 years ago when we
Yes,
were, cutting our teeth, as they say. So,
yes.
Prasanna, if you're good, can we start?
Yeah. How many do we have? Do we have at least over 20 now?
We have 25 right now,
Okay.
and rest of the people are still joining, so they can join
Right.
along the way.
Okay. Wonderful. All right. So why don't you kind of kickstart the discussion, Thomas?
Sure, I'll do it. So, a very
I'm
warm,
just going to
yeah,
share. I'm
sure,
just going to share my screen in the meantime. Okay.
sure.
Okay. Can you all see my screen?
Yes, Prasanna. Yeah.
Wonderful. Go ahead.
Okay. So, thank you for everyone for joining today's session, AI for Innovators, building your next AI solution. So, I know you've been waiting for the session to start. It's been 8 minutes, and we're really eager to move forward as well. So, thank you again for joining. So, first, I'd like to introduce our speakers for the day. So, we have Prasanna and Rajesh here. Prasanna is the founder of Idea Tribe. She's been passionate about the cause of lifelong learning, and she brings over 25 years of experience in the design and delivery of personalized skilling ecosystems. The initiatives she worked on has won several international awards and have resulted in 3 successful patent filings in the use of AI for talent transformation. Prasanna defines herself as an entrepreneur at heart and is most energized when she explores and converts ideas into functional and profitable ventures. So, like that introduction suggests, and like Prasanna mentioned before, she's really eager to talk to you, understand what you want to do, and help you build your next solution. So a warm welcome to you, Prasanna.
Thank you.
So next we have Rajesh Sampakumar, who's a data science and machine learning expert, one of the best people we could find for this session. So Rajesh is a senior director at Conferry. He's an experienced practitioner of data science and machine learning, experienced in solution consulting, solution architecture, and AI/ML approaches and technologies ranging from statistic modeling to generative AI, which has taken the world by storm. He has 2 decades of industry experience spanning manufacturing, telecommunications, and technology. We are so happy to have you here for this session, Rajesh. Looking forward to both of you speaking and engaging with the audience.
Thank you very much.
Over to
So,
you, Prasanna, Rajesh.
yeah, thank you, Thomas. So what I'm going to do now is kind of just set the stage for all of us. We have about 2 hours at hand, and what Rajesh and I are looking at doing now is to just share our experiences, in our AI ML journeys, and share some examples in terms of projects that we have worked on and the takeaways, from these projects, and then we want to have a discussion with you. So at any point in time, please feel free to stop us and ask us questions. But right towards the end of Rajesh's, presentation too, we will have a Q&A where you can ask us questions on any aspect related to the use of AI, technology or business, right? So that's going to take us about, an hour and a half in my view. And the last half an hour, we're going to focus on what I'm calling a pitchathon. It's about identifying, how you approach a problem, and then we have a small exercise for you, which you can, complete within a span of a week and upload onto a Google Drive link that I've shared in the presentation, and I will share with you guys as we go ahead. Now, that's basically the agenda. So 1.5 hours of discussion on AI and the potential, and half an hour on problem definition and the subsequent pitchathon exercise. Okay, so that's basically the agenda for the next 2 hours. And having said that, let me just hand the call over to Rajesh. Rajesh, I'm going to stop sharing and I'll let you share your screen. Rajesh?
Yeah, I'm just going to bring up my screen. Give me just a
Yeah.
second.
And while Rajesh is sharing the screen, I just want to underline the fact that I want this to be a discussion. So please feel free to, to chime in at any point in time. There are no stupid questions. Every question is important, and every discussion will have a great takeaway for all of us.
Absolutely. So I hope everybody can see my screen. Let me confirm that first. Can you all hear me?
Yes.
Okay, great. All right. So really excited to be speaking to all of you today. I'm excited not only for the presentation that I'm going to deliver here, but as Prasanna said, also for the discussion that follows. Now, I wanted to share my journey with you, not only my AI journey, which is directly relevant to this talk, but also something else about me as a person, about me as a professional, some of the things that have influenced me over time. And as you can see in all three pictures, I'm standing in front of some airplane. That's I think one of the early influences in my professional life. On the left, you find me at the Aero India show here in Bangalore, and on the right, it's again the Aero India show, but these are 20 years apart. So this was taken in 2003 with an old film camera that I still have in front of me here. And this on the right was taken with an SLR that I bought much more recently. So not only is this are these images a testament to how much has changed on the technology front with respect to imaging.
Rajesh? Did we lose Rajesh? Thomas?
Personally, right? These experiences in my own growth and change as an individual have seen me having the static hobby around aviation, and sometimes that hobby dips into profession. And there's different things that I've explored over the years. So, having said that, as a very rough introduction, I want to see how I can take you through some of the things that I've done in my career spans about 2 decades, about 20 years, and approximately the first 12 years were pretty much mechanical aerospace and automotive engineering. Those were not only my early passions, as I said in my career, but also became my work. And I started my career at a tractor manufacturing firm and worked in companies that produced mixer trucks like this one. This is a cement mixer truck, and one of the other companies that I worked with produced pumping stations like this. I worked on aerospace engineering teams. I worked on automotive engineering teams, and I worked with clients more recently in the AI and ML space to solve problems for them on solar tech, on renewable tech, wind energy, BFSI, or what's called finance or fintech, and most recently HR tech. Right. So that's what Conferi does. That's my employer currently. So this might give you an idea of the sort of experiences that I have had over the years, specifically about how I got into data science. I think you might all have that question. Look, this Rajesh has put up 3 or 4 pictures of airplanes, and there's all these other pictures about that have cars in them or planes or pumps or whatever else in them. But how come data and AI, and why data and AI? So I would say that one of the formative experiences in my career, in my engineering career, was statistical analysis and statistical problem solving. And statistical analysis is actually an extremely powerful toolkit in your tool belt, right? As a professional, if you know how to reason about data, if you know how to understand data, if you know how to look at problem statements through data, that can actually be extremely powerful for you in any arena, right? Let's say you want to be an engineer, you want to be an investor, you want to be a data scientist. Obviously, you're going to deal with data, you're going to deal with statistics. If you want to be an entrepreneur, if you want to be a creator, right? There's many ways in which data can actually help you. And the AI revolution that's happening right now is a testament to how data, computation, and business problems can intersect, right? So on the one hand, you have data that systems generate. On the other hand, you have computation and the scalable computation that you have these days. And on the other thing is business problems, because without having a business problem, and we'll discuss a lot more on that, you really can't go anywhere with your data and your computation, right? You'll just be producing prototypes. So the business problem becomes an anchor. And all of these pictures here, I want you to think of them as different business problems that gave me some insight, some context, some ideas. And based on those insights and context and ideas, I was able to explore how data and AI could solve problems for different businesses, right? And that's what I wanted to share with you at the outset about me as a person, my journey, my professional journey. And one of the things I want to mention is for any AI professional to be successful, for any innovator to use AI effectively, they've got to use data as a lens. You've got to use data as a lens to see a problem. What I mean by that is you might want to look at what data a system generates. What data can you collect from a situation? And how can you use that data to extract some insight or build a product or build a system that can help somebody solve a problem, right? So this data as a lens concept is actually really important, and AI as a lens. And as you learn about the capabilities of AI, we'll talk about some of them today. It's important to think about AI as a way of thinking about problems, right? AI is an approach to solving problems, and we'll talk about this as well. So those are a couple of things that I want to share with you right at the outset about my journey, the sort of experiences that I've had, and so on. So moving on, I want to talk about what AI means to me, right? And we'll spend a bit of time here. So all of you have heard the word artificial intelligence, right? All of you probably have notions about it. Now, I want to make this a little bit of a discussion, right? You see a few pictures and you see a few words on the screen. Some of you might know what computer vision is. Some of you might know what a smart chatbot or what ChatGPT is. Some of you might even know what time series forecasting is, right? I think that all of these are AI. So I want to know what else you think is AI. So anybody on the call willing to share their understanding of what AI is?
You mean as a definition or what I know about what AI does?
Anything, anything. So a definition is useful in a textbook, but in the real world, you have to have a really good understanding of what AI means, right? But let me keep that aside for a time being. Whatever you think AI means to you, just share that with me, and we'll see. We'll explore that idea. And this is purely exploratory. None of us is going to be like Sam Altman or the next big AI expert or Andrew Ng or somebody like that. If you know those names, like none of us are there. We're all exploring this space together in this conversation. So what do you think AI is?
Well, I think AI is a computer software or model which can think or create on its own.
Okay,
In a
that's a
usual program, we give clear
mm,
instructions about precisely what to do, but
yeah.
artificial intelligence can make decisions on its own. That's what I think.
That's a very interesting definition, right? And I want to draw attention to a couple of things that was said. I don't know who it was who was speaking. I wasn't able
Sri
to see the name.
Lakshmi. It was
Sri
Sri
Lakshmi.
Lakshmi.
Okay, great. So Sri Lakshmi, thank you for sharing that idea about what AI is from your perspective. You said a couple of important things that I want to draw attention to for everybody. AI is a system that's capable of taking decisions on its own. So that's capable of acting on its own. That is one sentence or one phrase I heard. Another phrase I heard was, you don't have to give it instructions, right? So, in fact, those are very, very close to the target. So, I want to really give a round of applause for Sri Lakshmi for coming up with that response. That's really helpful for us in this conversation, right? So, thank you very much, right, Sri Lakshmi? That was great. Now, why I want to draw attention to those two things are AI is indeed a set of techniques where you don't explicitly program a computer to do something, right? So Sri Lakshmi was spot on about that. But I also want to add that it's not the case that you don't give any instruction at all. So I want to qualify that statement, right? I want to say that you use data, right? And systems that learn from data, which is basically machine learning systems, right? Those systems are capable of exhibiting artificial intelligence, right? So artificial intelligence is a phenomenon where some synthetic system, some system that human beings have created, can exhibit certain characteristics of intelligence, right? Some synthetic system that we've created exhibits certain characteristics of intelligence. And one set of techniques that's very popular in the world today about getting, in terms of getting to that level of intelligence or that sense of intelligence is machine learning, right? So machine learning is a way for us to use data to train a piece of software to actually take certain decisions autonomously, right? Now you'll all be thinking about what data I feed it and how do I train it, right? So we'll certainly get to some of those things. We'll certainly discuss them in context. So anybody else wants to volunteer an answer? Anybody else wants to share what they think about AI?
Yes. Hello. Okay. I believe that AI is something that can grow or learn like from what we give to it. It's like something that can grow over time.
That's fantastic. That's a very good thought as well. And it is indeed possible to train and retrain AI models, to Deva Prabha's point. So what she's saying is that if you give some data to an AI, and I'll qualify this based on what I said earlier, if you give some data to an AI model, the model is able to learn capabilities. But then if you give some more data to that AI model, that model can learn new capabilities or different capabilities if you do it right, right? So the key is how good your data is, how you train your model, all that stuff, right? We can discuss all that, but that's a good point as well, right? So thank you, Deva Prabha. Anybody else wants to volunteer a suggestion or an answer here?
Yeah, I would like to.
Yeah, go ahead, Anish.
I interpret AI as a series of a set of algorithms which uses pre-trained data, which uses data which it already has to
Mhm.
perform a series of operations and, if possible, give a series of recommendations.
Okay, so
Um,
you brought up a few things there, Anish. So you said data sets, you said something about recommendations, right? So I think recommendation systems are actually a certain class of AI techniques, and we'll talk about that. But those are good points. I think you are right in saying that we give training data to the AI model. That's essential for the AI model to be able to perform a certain action. So you train it how to perform an action, and then it performs that action, right? Using the by virtue of the data that you've supplied to it. So that's a good point. And you also rightly said that you know uh, AI can perform autonomous actions based on whatever data you give it. So that's in line with what we discussed from Sri Lakshmi and Deva Prabha's answer earlier. So great points from all three of you. Anybody else wants to make a suggestion or volunteer some ideas on what AI is?
Hello.
Yeah, go ahead, Shubham. I can hear you.
Sir, AI can be something that builds the new pattern on its own by analyzing previous data, like AlphaZero.
Fair enough. Yeah. So Alpha Zero is a specific example of an advanced AI model. Alpha Zero and Alpha Go, these are models developed by a company called DeepMind, right? So DeepMind is part of the broader Google company, Alphabet and Google. So what Shubham is referring to is you can generate new patterns based on patterns that have been seen earlier, which is a fantastic point. In fact, all of us have heard about ChatGPT. That word is on the screen right now. ChatGPT is an example of an AI model or an AI application that can generate text for you. It can generate code for you, right? It can generate software programs for you, right? So these are examples of software applications that have been trained on data that can do specific tasks for us, right? So thanks everybody for the enthusiastic set of answers that we've got. And it's very important that we all sort of engage like this with the presentation. Now, coming back to this slide, right, I want to point out a few things that are really important for us for the rest of this conversation. There are different kinds of AI. AI is not just one piece of software or one thing, right? Based on the kind of data that you train the model on, based on the kind of model and what's called the model architecture, based on the application, more importantly, right, of the technique that you're talking about, you can have different kinds of AI, right? So AI is a combination of not only techniques but also applications, right? And how those applications sort of, are solved. There's a set of problems there that those are solved by using your AI techniques, right? So in the technology world, right, in the technology universe, a lot of us tend to over obsess about what is the technique, what is the software package, what is the company that developed this, and all those are things to certainly consider, right? But I also want us to think about applications because innovation happens at the intersection of techniques and domains, right? So if you have a technique and you apply that to a domain to solve a problem, then you can create new value, you can innovate, right? So we'll come to innovation as well. There is a small, very, very simple framework that Prasanna and I want to share with you about how to innovate in the context of AI, and we'll certainly discuss that. But here you see that there's computer vision capabilities. That's the image on the left. That shows a car where there are objects in the field of view of the driver, right? So let's say that you're sitting in the car, but this is not an ordinary car. It's a self-driving car, right? This is a self-driving car that can drive itself. So input to the engine, your brake, accelerator, your steering input, all of that stuff is taken care of by a robot. And that robot is powered by some kind of an algorithm or some kind of an AI model. So what you see there are red boxes and blue boxes and things like that. Those are what are called bounding boxes. And you see that there is also some kind of direction, some kind of navigation assistance that's given. Other cars are also demarcated out there in the image. So that's an example of a computer vision system that's able to detect an object. It's able to detect that there's a cyclist, that there are other cars, that there is a road, and it's able to. So all of those are capabilities, right? So if a computer vision system has to be built for a car, for a self-driving car, then you should be able to tell, just like a human, that this is a car in my field of view. This is a person, that is a little girl, this is a granny, etc. So I don't want to run into some of those things, and I want to make sure that I'm on the road, right? So that's what makes a good self-driving car. And all of you can look up what Mercedes is doing, what Tesla is doing on self-driving cars. There are different levels. There's 5 levels of self-driving and so on. So that's probably out of the scope of our discussion today. Now, I want to move on to the next thing that we see here on the screen, ChatGPT, right? How many of you have used ChatGPT? I think maybe the better question is how many of you have not used ChatGPT, right? I think the better question, like I said, was how many of you have not used? I see a lot of hands go up, so I'm very excited to know that so many people have used ChatGPT. It's really fantastic to know that there's such a technology out there that's available for free, and that can be used to generate very correct, grammatically correct text. You can generate code from it. It can follow instructions and give you specific types of answers. So it's a remarkable application, isn't it? I mean, all of us, I'm sure, are in love with ChatGPT, right? So I think ChatGPT is an excellent example of what generative natural language processing can do. So earlier I talked about computer vision. Computer vision is this capability to look at an image or a video and then find different things about that image and video. And all those little things that you find are part of the intelligence or the capability that that model has. Similarly, if I want to deal with text data, let's say I have a lot of text, right? I might be interested in how that text is structured. Is the sentence written in a particular way? Is this a poem or is it prose, right? Do I have a particular style of writing? Is the punctuations correct? There's so many things that are going to be happening in a passage of text, and everybody who reads text on a daily basis, when you read a news article, when you read a book, you take all this stuff for granted because we as humans have sophisticated natural language processing going on inside our heads, and we don't really understand most of what's going on in there. But with Chat GPT, right, what's really come out in the AI space is how sophisticated uh, models have to be in order to reach that kind of capability, how complex they have to be, how much data they need, how much tuning and fine tuning they require, right? So those are natural language capabilities, and natural language capabilities can extend to things like generating natural language, parsing an existing paragraph that I feed in. Maybe I type in something and then it tells me, look, these are the nouns in this, these are the parts of speech, for example. Or if I want to find all the names that are present in a paragraph, I'm able to find the names. If I want to find all the prepositions, for example. Right, so those are basic capabilities, and there's more advanced capabilities like generating text, generating code, generating instructions, right? And then I want to come to what many of you may not think is a form of AI, right? And that's very important to discuss as well, because it's not always obvious that people are talking about chatbots, people are talking about self-driving cars. So it's easy to miss the more common use cases, right? It's easy to miss things like time series forecasting. How do people use AI in a bank? How do they use it in an investment bank? Or how might they use it, say, for sensor data? Let's say I have a set of sensor data that's coming in from a medical device, or I have a set of sensor data that's coming in from a car, maybe some other kind of data apart from just the camera and other stuff. So there's a need for something called time series forecasting, time series analysis, right? And forecasting is one specific example I've given here, but time series analysis is a broader area in general. And you'll find that that kind of capability is also called AI, right? There are very simple models, much more limited than the complex ones like ChatGPT, which can also be considered AI if they are applied correctly, if they can be used to deliver some really excellent intelligence capabilities, right? So thanks everybody for a very hearty discussion on this topic, right? So this is one more manifestation of what AI means to me as a person, right? So it's not just computer vision, chat GPT, but also things like time series forecasting. It's also simpler models, smaller models that may be used in small business applications. And if you ask me, not only is there great opportunity in building the next chat GPT or building the next self-driving car, but there's also great opportunity at the intersection of some business problem and something very, very simple, a very simple model that is based on good data, that's based on a correctly thought out model, right? So these are some things that I wanted to mention on what is AI to me, right? And now I'm going to take the discussion in a slightly different direction. right? Now, what you're seeing on the screen is what's called a mind map, right? So on the right side, and we talked about applications and techniques earlier, right? We talked about how AI is not only about techniques, and those of us who are techies, right? We tend to obsess a lot more about techniques, but we don't obsess a lot about applications, right? I'm saying this very earnestly because I think I might have been guilty of it several years ago, right? I also hope that youngsters out here who are innovating, right, that you really look at the business problem and the application area as much as you study about the techniques, or as much as you spend time on learning about statistical modeling or machine learning techniques, right? Because a lot of technology professionals go down that path of learning about machine learning, learning about deep learning. Can I learn TensorFlow? Can I learn PyTorch? Can I learn how to Dockerize an application, put it on Kubernetes? And those terms might make sense to those of you who are techies. And for those of you who are not techies, right, don't worry. I'm not saying anything of substance here, right? What I'm trying to say is that it's good to know the technology aspects, but it's also very important to understand the applications. That's my main discussion that I want to have in this slide, right? We've talked about ChatGPT earlier. We've talked about computer vision, right, as applied to self-driving cars. Now, in those examples, I talked to you about how, there's image and video classification, meaning if I have an image, then I know that that image has a person in it or a car in it. For example, I could be detecting objects in an image, such as this is a girl on a bike, or this is a car, or this is a granny crossing the road, this is a dog crossing the road, for example. And object tracking. So once I've detected where a particular object is, as I move forward, I'm collecting new frames in my computer vision, in my camera, right, for my car, and I need to track, where that, how fast that thing is moving, how fast that object is moving, etc. So that's an object tracking problem. And there's also region segmentation. So I need to know where the road is and what is the road and what is not the road in my image, right? So all of these are fundamental intelligence capabilities that we take for granted. When I sit in a car, or when I sit on a bike, and when I'm riding or driving, all these things are obvious to me because I have human intelligence. To make a machine do similar things, we've got to think about what the sub problems are. And these are some of the sub problems that I talked about in computer vision, specifically for self-driving cars. There are other applications. We'll talk about one cool use case from my past history, right? That's computer vision. Now, natural language processing. We've talked about some capabilities of ChatGPT, generating text, right? But there are a few other problem statements over there. Some of you might have heard of information retrieval. Those of you who are computer science graduates. It's a way of saying that I want to pull a specific pattern of data or information from a large set of data that's already present. That's information retrieval, right? And then there's language translation, right? I think this is a capability that has grown by leaps and bounds in the last few years. You'll find that Google or Microsoft or these big tech companies, they're not only investing a lot in translation capabilities, but they're also building great applications that are meant for translation, right? So translating from Japanese to Hindi, for example, or translating from Kannada to Tamil, or translating from Malayalam to Telugu or something, right? So all of these are different translation capabilities for natural language. And then there's natural language generation, which I think all of you are familiar with ChatGPT already, so I won't mention that once again. Now, named entity recognition, that's a specific problem where I have a bunch of text and I want to tell if there's a certain pattern to some of the words, and I want to find all those words which match that pattern, right? That's named entity recognition. And then there's speech to text, right? So I volunteer speech data and I get back the text version of that, right? So this is a way of transcribing what I say in a call, for example, or if I'm reading out to my phone, then it types it out in a message. We already have many of these capabilities, right? Now, amongst the other applications, right, we have time series analysis, where let's say stock prices are going up and down, and you want to know if the stock price tomorrow is going to be higher or lower. So you want to know whether to make a decision to buy or sell more stock, right? Because you always want to buy when it is low, and you always want to sell when the stock price is high, so that you can make a profit. So that kind of analysis is time series analysis. So there are ways of doing that with one variable, with just the stock price alone. Maybe there are other factors, right? Maybe there's some recent news about something that a company did, which is cool. So their stock price goes up, right? There's examples like that. And then let's say I'm doing something very, very simple for my sales operations in some company. My company has been selling something. Maybe they're selling Pepsi, or maybe they're selling food, or maybe they're a logistics company. And I want to know how my demand is going to vary. Is my demand going up? Is my demand going down? Can I model that using some mathematical function? So that's time series forecasting, right? And let's say that there's some unusual events. Maybe there's a Diwali sale and I get a huge amount of traffic on some e-commerce website. So those situations, or maybe there's an attack. Maybe somebody is trying to compromise my website by sending many, many requests to it. Or maybe many people are trying to log into my website to cause a crash. So those are situations where I might use something like anomaly detection, right? That's a set of techniques where I say, historically, this is the pattern, and suddenly I see that the pattern has changed. So that's an anomaly, right? So there's a statistical way of doing that. Now, those are also AI applications, right? Now, robotics, and we've talked about self-driving cars, which are kind of like robots, and they're robotic cars basically. But in general, robotics also requires a couple of areas called trajectory planning and optimal control. And these could also use artificial intelligence. Somebody else already mentioned Netflix, right? Somebody mentioned different kinds of recommender systems, which might be part of artificial intelligence. So you can see that that's also an application of artificial intelligence, right? There are different techniques, right? So those are on the right. You'll find that there are simple techniques like describing your data, trying to do statistical inference, right, with your data to tell if data comes from a certain distribution or not. Those of you who might know some statistics might understand this. But in general, right, machine learning is an applied version of statistics. You can think of it as an applied version of statistics that's used to solve all these different kinds of problems, all these different applications, right? So you might be using, say, a deep learning network to do time series forecasting. You might also be using a deep learning network to do computer vision or natural language processing, right? You might be using a discriminative learning model for recommender systems, etc., etc. So there are different ways of mixing and matching techniques and applications, right? So I think I might have covered a lot of ground on this slide. So I want to pause for a minute and try to understand if anybody has questions about this. We can certainly discuss if you have any thoughts or questions, or you want to share something with the broader audience about something you know. That would also be great.
Excuse me, sir.
Yeah, go ahead, Angad. You have a
Sir,
question.
actually, I want to ask that have you, as you have already said about that translation model of an AI.
Yeah.
So I just like to know that can we use that plugin to another website or any other app?
Right. So, Angad, your question is, if I understand your question correctly, let me repeat it for everybody's benefit. I have a translation model, and I want to use that not only in one website, but multiple websites. Am I right?
Yes sir, also but मेरे को पूछना था सर कि plugin कैसे यूज कर सकते हैं किसी वेबसाइट में अपन plugin करके उसकी ट्रांसलेशन लैंग्वेज चेंज कर पाए.
Right. So I think Angad's question, if I were to reword it in English again for everybody, you have a translation model which takes text in one language and translates it into text in another language. This is the fundamental capability of that model. Can we use a plugin to apply that to different websites? That's one kind of question. The other is, can I use the same natural language processing capability to translate from one language to another in different applications? So this is a great question. Thank you, Angad, for asking it. So my response to that is yes, it is possible. We have to decouple the application from the model. That's what is important here. So I have an application which might be a website, or it could be a mobile phone application, or it could be anything else. And then I have a model. Imagine that model is somewhere here. And that model does the job of taking input in a language and converting it into output in some other language. So this application down below has to run as a service, and that service should be able to connect to whichever uh, application, mobile app, or website, or anything else which is on top. And by connecting to it, it can actually receive information from there and send back information to there, right? So it can receive text information from the website and send back translated text to the website. It can receive, text information from an app and send back text information to the app, right? And what does it receive? It receives some text and it sends back translated language, right? So that is possible, and this has to do with something called machine learning operations, right? So machine learning operations is a subset of the broader AI space where your primary focus is how do I productionize and deploy my application. So I have built an application, I have built an AI model, but just training the model alone will not help me take it to production, take it to a useful production grade application. I have to actually use something called ML ops, which involves the deployment of these applications, these ML models or AI models. And once I have deployed the ML model or AI model, I can use standard network protocols to communicate with the AI model or ML model. And that would be my approach to solving that problem, right? So Angad, I hope I answered your question.
Yes, sir.
Okay, thank you. Somebody else had, I think Meera had
Yes,
had a
sir.
hand up.
Yes, sir. What was an example for a trajectory planning in robotics? Maybe in the cricket, or what will be the real time application for it?
Great, that's a fantastic question. So Meera, you might have heard of industrial robots. Has
Yes, sir.
anybody heard of industrial robots? So industrial
Yes.
robots are different from. So when we say robot, right, to the average person, what appears in their mind is some kind of human-like form with, the ability to have hands moving and legs moving and so forth. But most robots, in fact, that are used in the industry tend to be six-axis robots. So they will have the capability of a typical human hand or something more complex than that. So these might be used to pick up an object and place it somewhere else. So the same range of motion that my arm is giving me when I pick up an object and place it somewhere else, I get that same range of motion with the mechanism that's used in those six-axis or 10-axis or 20-axis robots, right? So in order to plan how this robot has to pick up an object and place it, right? I need something called trajectory planning, right? So that's what trajectory planning means. So trajectory planning is an activity where I tell my robot, this is the set of instructions you have to follow in order to pick up an object and then place it. So traditionally, how would we do this? We would actually specify every one of those rules. The robot will be working in a very controlled environment. We will always have parts in a shop floor present in one location. Those parts will always have to be picked up from that location and placed in another specific location, for example, or processed, right? So that process was very controlled and very rule based, right? So we would issue specific instructions. But with AI, what's happening is we have computer vision. So if you put a camera at the end of that six-axis robot hand, and if you put object detection there, you can take uh, decisions at the robot end itself on what to pick up and what not pick up, and what to place. Similarly, if you want optimal control, I want, let's say, my car to keep a steady speed on the highway. And when the car in the front has decelerated, when it has reduced in speed, I don't want to crash into it. So I want to keep a minimum distance. So that's an optimal control problem, right? That's a problem statement where I have, the ability to control where my. So that is also an AI capability because you're collecting sensor data from the systems in real time and you're responding by using input. And the decision that you're taking in the process is done using an AI model, right? So that would be my explanation for trajectory planning and optimal control. So does that help, Meera? Does that answer your question?
Yes, sir. Thank you, sir.
You're
So
welcome.
Sri Lakshmi has raised her hand.
Yeah, go ahead, Sri Lakshmi. Yeah.
Sir, my question is, how do we connect these NLP models to, let's say, a website or a software? Are we going to use an API or something?
Yes, that's right. So Sri Lakshmi, you're absolutely right. We will use an API. We could use a REST API, like a RESTful interface, which might use HTTP or HTTPS kind of connections. And if you want to know more about how that is done, you can get in touch with me. We can discuss that, right? It might be a little too technical for this audience, but yeah, we will generally use a REST or similar API with post or get endpoints, right? That's the general mechanism.
Any more questions?
Any more
Otherwise,
questions? So Angad, I'll get in touch with you. Maybe you can reach out to either Prasanna or the organizers and get my coordinates, and we can connect on that.
yeah.
Okay, sir.
Thank you. Anybody else? Any other questions, folks? So again, I want to jog us back to why we're talking in this kind of detail, right? It's important to understand that AI is not only about techniques. It's not only about deep learning. It's not only about support vector machines. It's not only about time series forecasting, but it is about using those techniques in the context of a business problem. Right? So that's what I want to emphasize here. All of these things that you see on the left, all of these applications, they have all arisen because of the fact that we had some techniques and those techniques had to be used to solve a problem. And then that became an area in itself. So NLP happened because people were trying to use statistics on text data. Computer vision happened because they were trying to use statistics in computational engineering on image data and video data and so on and so forth, right? So it's important for us to be cognizant of the applications, right? So if we are good, then I'll proceed to the next slide. Does anybody still have any questions?
Sir, I just like to ask that does AI can store your data permanently?
Okay, that's a very good question. Maybe slightly out of the scope of what we're discussing today, but I will certainly answer that. So I think there is a lot of fear about how data collection happens and how that might be used against us. I think it's a very legitimate concern. And the answer to your question, I would say, Angad, is not necessarily, right? It may not always be the case that the developer who has built the AI model is going to use your data to store the data and use it in some way, or use it for training your model, right? So that may not always be the case. However, it has been known to be done, right? So even OpenAI, when they released ChatGPT, they said, look, we won't, I mean, they had to issue a statement probably about 2 or 3 months down the line saying, no, we will not use your data to train our model. But until then, there was no such statement from OpenAI, who are the developers of ChatGPT. So my response to that would be, Angad, if you are going to use an AI model, especially if you're using it for business purposes, my suggestion would be to read all the fine print and understand whether they're going to use data that we supply for training or for any other purposes. So to answer the question of whether they will store it permanently, right? That's also mostly not possible. So there are limitations of data storage systems, and when a large number of people start using an application, a large amount of data gets generated. And if you have the ability to store a large amount of data, you're also going to be paying a large amount of money to be able to store that large amount of data. So I think it's a trade-off. Many companies have to decide, is this data worth keeping? Do I have to keep all of this data, or can I get rid of some of this data? Can I archive it, or can I delete old data? So those questions, each company might answer in a different way. So these are some things for us to be aware of when we engage with or when we develop with artificial intelligence models, right? So thank you for that question, Angad. Anybody else has any other questions?
I guess it's time for us to have a bit of a discussion. I want to hear what we have to say, Rajesh. So maybe we could proceed and kind of get to some of the
Absolutely.
discussion.
All right. So let me move on. I think we have 3 interesting scenarios where I want you all to think about not only the stuff that we talked about earlier, but what applications and techniques might be used, right? So the first one is, let's imagine that you are building a self-driving car, right? You may not be a person who knows about cars that much. You may not be a person who knows about AI that much. But based on what you've learned in this discussion so far, based on what I have told you earlier, what do you think are some AI applications and techniques that you will use in a self-driving car if you're building it from scratch? Let's say that even the metal is not cut, tires are not available, nothing is there. You have a blueprint, right? And you want to go from there to having an actual car in say 3 or 4 years, whatever that time frame is. What AI applications and techniques will you use in that car?
Um, Image recognition and speed and the ability to understand the speed of the car, and B, also understand the speed limit of that road to maintain my car's speed limit within that.
Very cool. So Anish, you're saying I need to be able to understand what the image contains when I get an image from the car. So presumably I'll have a camera on the car. I'll have some kind of camera that's collecting some image data. And you also mentioned speed, right? Does anybody know how speed can be measured using a sensor? What kind of sensor might be required?
Accelerometer.
All right, you can use an accelerometer. All right. Any other ways of measuring speed? How do you measure relative speed of other objects? How do you measure relative speed of other objects coming towards you or going away from you? Has anybody seen policemen holding something on the highways when you're driving? Right? There is a technology called radar. Have all of you heard of it?
Yes.
Radio. Yeah. So
Uh,
radio detection and ranging, right? So you issue a set of radio waves at a certain frequency that bounces off an object, and then you can, by using the time difference, you can compute how fast that object is. So you can put sensors like that. So to Anish's point, you can put a camera. You can also put a sensor like a radar sensor. Anybody else knows any other sensors that might be used?
You can also use LiDAR.
Good point, Deva. So Devanarayanan has a point on using LiDAR. So what is LiDAR? Anybody knows what LiDAR is?
Light detection and ranging.
Okay. So yeah, it does something similar to what radar does, but does it using light or electromagnetic radiation in general, which is obviously much faster than sound, right? And the interference that you might get from other sounds in the vicinity won't be present with light detection and ranging. LiDAR scanners are there even in mobile phones and iPads these days. So that's a common sensor technology that you can use, right? Anybody else has any other ideas on what other sensors or technologies or AI applications can be used?
Fog detection mechanism to identify the fog, and also we can use, I think it's a random forest algorithm can be used to classify objects for object detection, maybe a person, a traveler or something, if the boarding point, etc., can be calculated, and it's under the future scope of AI. So
Sure.
that's what.
Well, a couple of points there. So you mentioned that fog detection is a useful capability, and I agree it is. Viewing conditions may not be very good in many places. Let's say you're driving around in Delhi and it's one of those months like October or November. You will have problems like stubble burning and stuff because of which there is a lot of fog or there's a lot of smog. So your visibility may not be great. So those are use cases for using LiDAR to detect objects that are in front of you, right? So that's a good point. You also mentioned a specific algorithm. So I think you mentioned random forests for object detection. Certainly, random forests or other such tree-based models can be used for object detection, but it's not the normal practice these days. What we use is something called non-max suppression using a deep learning network. But I won't go into technical details there. I want to keep the technical discussions out of this, but I want to discuss the broader technique. But shout out to Meera for bringing up the fact that you might use a machine learning model for detecting where objects might be, right? When a person gets on, gets off, things like that. So thank you very much, Meera, for that idea. Anybody else
Thank
wants
you,
to
sir.
share anything else?
Sir, can we predict traffic conditions? Like
It's a
lots of
fantastic,
data might be already
absolutely.
available. We can train easily.
Absolutely, that's a fantastic idea, right? So, what if your self-driving car also has to be fuel efficient? When do you know how to turn off engines? When do you know how to go slowly because there's traffic ahead? We have data, right? As when you're driving a car, you only have visibility of the road in front of you. But when you're connected to the internet and when you're a self-driving vehicle, you have the ability to say, ping some API. You can ask some API, what kind of traffic is there ahead of me, things like that, right? So there's many ways in which you can get data, and through that, you can navigate your car better. You can you can do trajectory planning better, right? So remember, trajectory planning is one of the things that we discussed as a robotics capability. So the trajectory planning is something that you can do very well if you have lots of data about what roads are in front of you, how good quality the roads are, etc. Right? That's a very good point, Sri Lakshmi. Any other discussions? Anything else people want to bring up? There's many others
Rajesh,
on the call. Yeah,
yeah, Rajesh, just wanted to do a quick time check, Rajesh Prasanna
yeah.
here. We have only about 40 minutes to close on the tech part
On the
of the
present.
discussion.
Right,
Yes.
great. All right, excellent. So we'll move on to another example in the interest of variety, right?
Yeah.
Now, so what you see here in the next one is something all of you might be really interested and passionate about. I've already heard a few questions about language models, translation, ChatGPT. So imagine that you are building, and Sam Altman, who is the CEO of the company that builds ChatGPT, was in India recently, and there's some words being exchanged between Mahindra and him. If you've all been following the news this morning, so let's say India wants to build the next ChatGPT competitor, and one of you folks is the smart person behind that application. What applications and techniques will you use from what you learned today, or from what you know about AI in general, for building this kind of an app?
So other than natural language processing, I would like to add computer vision capabilities to my product so that it can be used as a Google Lens, for example, and take input from images as well.
Okay, that's a very interesting idea. So can we look at images that are present on the web and reason about them in addition to just interacting with text data? So that's a very interesting idea. So that's one possible application or technique.
So we
But
can make flow charts over that can be easy to learn, as well as the technical diagrams that can learn easy.
right, but which AI techniques will you use, Angad? I mean, you've learned about some AI techniques like generative modeling, or you learned about deep learning in the previous slide. I discussed that very briefly. Do you think any of those techniques can be used for building something like a competitor for ChatGPT?
So generative image might be.
So generative image processing, so image generation. You're saying that. So that's similar to what Sri Lakshmi was saying earlier, where you use either existing images or you're able to generate new images. So that's very interesting. I believe that Bing already has that capability. If you've seen what Bing AI can do, it can generate images for you. So that's very interesting to know that we are also thinking along those lines. Angad, so thank you for that. Anybody else wants to give any answers?
Yes, sir. I will prefer it for a 3D models or building up of interactive 3D models with of applied way of statistics or computation. Uh,
So what do you think? Why do you think we would introduce a 3D model there, Mira? What is the thinking behind your suggestion?
because we need some for applied researchers or development. We are in a lack of. We have only textual or conceptual knowledge about
Hmm.
anything. If it is in a medicine or any other applied fields of physics, we need to deeper go into research and developments for
Yeah,
any of the physical models or
I understand.
atomic models. So we need of building of an interactive 3D models. So
That's interesting. Admittedly, this is a use case that very few general public will might use, but it is there, right? So that might be one feature that you want to, as a product thinker, you might want to discuss whether that feature is relevant to your audience. Is it a good idea to include something like that? How many people will use it? So I think those kinds of questions will have to be there about some of these features we want to add, right? But generally speaking, the applications and techniques that we will use, right? So that's what I want to touch upon a little. So ChatGPT uses what's called a transformer model. right? And for those of you who want to learn about some of the technical aspects of AI, it will be good to understand what transformer models are and how we got to transformer models after a lot of different architectures. So that might be one area that you might want to take a look at. And I think the suggestions from different people on the call about using image data or generating images, all of those are great suggestions. I think there may be room for video generation, audio generation along similar lines. So those are all great capabilities. Imagine if you had a chatbot that could speak to you instead of just give you text, right? So what if there could be text to speech or reverse transcription, right? So those are some ideas around ChatGPT, right? I'm sure this is a superb area to brainstorm with you and your friends or your project team members or anybody else at work. If you want to think about different ChatGPT type ideas, I'm sure all of you can spend some time discussing it. I hope that we've given you some fodder for all those discussions. Now, imagine, all of you might have, some of you might have seen IPL at least. I think most of you might have seen IPL. Who doesn't watch IPL here? Let me ask the question in the other way. Oh, so Prasanna doesn't watch IPL. Okay, I should have probably checked with you before. All right, I watch IPL, right? I think many others on the call might be watching IPL. Anyway, IPL this time was delivered on Jio Cinema, which is a homegrown content platform from Reliance, right? So that's something I want to point out because I mean, as much as we might think that, look, all is done and dusted, movies are always going to be on Netflix or Hotstar or one of these big over-the-top providers, there is room for innovation, and we may not know it, but there is room for innovation. So sometimes that innovation might come in the form of a new content platform altogether. So let's say you're building your own content platform. It may not even be something that competes with Netflix, but something that does similar things for a much more focused audience, right? So what kind of AI applications do you think would you use if you're building some Netflix competitor or something like Netflix, but for a different kind of a area?
Sir,
Personalized
might
platform.
be two user
Yeah,
thing.
one at a
Might
time, please. So I think Deva, you were going to say something. Can I go to you first? Deva
Yeah,
Narayanan.
I
Yeah.
would say personalized content would be the biggest.
Personalized content. Okay, great. So this assumes that we already have content on the platform. There's plenty of content that's available. So there is a different individuals are different. We might all have different tastes. So Deva's idea here is, can we customize or personalize some of that content so that it matches the person? So what techniques would you use? So we talked about AI applications, which is personalization. What techniques have you learned in the discussion today, which could be used for something like that, Deva?
Deep learning can be used.
Yeah, deep learning is one kind of algorithm or one kind of technique that could be used. But can you refer to something specific? What kind of deep learning model? Because deep learning could be used for anything from image recognition or object recognition in images all the way to time series analysis or anything else. Can you dig a
So
little deeper? Any specific kind of
no,
deep
I
learning?
can't. I'm not that into technical stuff like that. I'm not
No,
everything.
that's good, right? That's good, right? It's a very good
Mm.
intuition that, look, I mean, when we have content, we need personalization. That is a very good insight. That's a product level insight, right? So kudos to Deva for coming up with that. So I think Angad, you had a question, so let's go to you next.
Yes, sir. I just want to say that as we are using Netflix, we can install an camera which analyze our emotion, and that can be helpful for changing the emotion or making a personalized content like Deva has said.
Okay. Well, this is taking personalization to the next level. So you're saying, look, not only do I want to just give personalization based on content that's already there on the platform, but I'm going to really go to the next level and collect information in real time about somebody who's viewing a piece of content to understand if they're happy or sad, or if something, if they have a different emotion with respect to the content, and then personalize the content based on that. So it's a really interesting idea. So I think we discussed about data and privacy in a slightly different thread. So this kind of intersects with that thread also, because there is going to be an element of fear or uncertainty or doubt when there is a corporation that's tracking your emotions. But and it's a very personal thing for a lot of people, to be recorded for maybe their eyesight or their expressions to be recorded. as they're watching something. But if even despite all of that, if there is interest, that could actually be a very viable business, because there are phone-based face unlock applications these days, right? So when I open up my iPhone or other Android device, I can actually use my face to unlock the device. That means that that device is collecting my face every single time I unlock. So why can't we extend it here? That's a very good suggestion or a question. Anybody else? So I've seen a lot of responses from Sri Lakshmi, Deva, Angad, Meera, Anish.
Um,
Anybody else wants to volunteer any ideas? There are 20
yeah,
or so others.
yeah. What I suggest is for the big content, it's a user who decides the content. It's like a set of choices. There is a content like similar to Netflix, but the decision how the story has to go on. If it's just the user
So
needs
the
a happy
decision lies
ending.
with the user, you're saying. Okay, that's
Yeah.
interesting. That's
Yeah, so
interesting.
it's
So
a
how would you build something like that, Meera? And let's say that
um,
I take a decision. Every person is going to be different, right? Maybe they
yeah.
type in what they think the ending should be, or they type in how they think the story should go next.
Yeah.
What would you do in that case? How would you use machine learning to give them what they want?
Maybe with some decision making algorithms building such things.
Mhm.
I'm not clear about that, very clear about
Okay.
that.
Well, I think these are great points of discussion, right? So, Meera, I hope you got some interesting idea from there, from what we discussed, right? So, and
Yes,
I
sir.
think same with Angad and Deva. I think you're all making excellent suggestions here. Anybody else wants to add something on Netflix or some other applications, content platforms before we move on?
So I would like to take this to next level.
Okay.
This might be a little okay. Let me tell this.
Yeah.
What about a brain chip that collects our data from brain, like
Okay.
how we like all of the shows
Hmm.
and personalized content according to what we actually feel.
That's fantastic. That's fantastic. I think this is what one of Elon Musk's companies is trying to do with
Yes.
embedding chips in brains and so on. That's almost a dystopian suggestion, Sri Lakshmi. Sorry for saying this, but I found myself actually horrified for a second when you said chip in my brain, because I got very scared for a second. But it's a very cool idea, right? Think about it. There could be some great application out there that, I mean, let's say that there's a really old person who's vegetative, who's unable to move. They want to experience some of their memories from the past, for example, and they're unable to open their eyes or something like that. What if there was a possibility of transmitting some of this stuff into their brains, right? It sounds like science fiction, but we all know that science fiction becomes science fact with enough blood, sweat, and tears, right, as they say. So that's a very interesting suggestion, Sri Lakshmi. I think it might even have a use case in the future. It's it's completely out of the box, right? That's fantastic. So congrats on giving that suggestion here. So great. So anybody else wants
Rajeshri,
to?
we
Yeah.
have to move on. I'm so sorry
All right.
to be
Great. No, this is
the
great. This is
nag.
great.
Yeah.
All right. Now we've discussed a lot of different businesses. We talked about Netflix. We talked about some of the other companies like ChatGPT, self-driving cars, Tesla, all that stuff. But I want to come back and anchor us to something which is very fundamental, right? Because all of us are thinking through all these cool ideas, so it's easy to lose track of what we're trying to solve. And what we're trying to solve ultimately is a business problem, right? So what I've shown in this very, very simple graphic is how do you actually solve problems using data and artificial intelligence, right? So you always start with the business problem. You see where the arrows start? The arrows start out here. All the arrows, they point back to the business problem. So the business problem should be the source of inspiration for us to try to solve a domain specific problem, some kind of application that will become a product for somebody else, some user, right? So what could that business problem be? For Netflix, that could be different people are different, and I want to know how to match people with the right content. So that's a recommendation system. For Tesla or anybody else who's developing self-driving cars, that would be, I want a machine to drive itself, and I have a limited set of sensors and sensor data with which I can do that. So how do I use that sensor data, such as images, radar, lidar, etc., to solve these kinds of problems and navigate the car, right? So that's my business problem. It could be a product problem, right? And ChatGPT might have a different problem, such as I want any end user to be able to, any end user, regardless of their language skills, to be able to write an essay based on some suggestion that people give. And what if there was an app that could actually automatically write essays for people? What if there was an app that could generate code for people? So that's their business problem. And how did they frame that? I mean, they frame that business problem as a data science problem, as an AI problem, right? So in each of these business problems, there is a data as a lens opportunity. So I talked about how I like to use data as a lens, right? And I talked about how you can ask questions about how a system is generating data. What kind of data is a system generating? What kind of algorithms can I use to make sense of that data? So that is data and AI problem and data and AI solution. So I take a business problem, I convert that into a data science problem or an AI problem. So I talk about what data I collect from that system, how will I analyze that data, how will I use that data, what algorithms can I use, and we've learned some AI techniques in the past. So how can I put a solution together or a product based on all of these mathematical techniques? Because the mathematical techniques themselves are useless unless I can productize or productionize and deploy that application, right? So only then I get a business solution. Only then I can get a solution I can take to the market. I can't take a solution to the market if I have no way of having an end user use that solution. So this is where software engineering comes in. We need software engineering and data engineering and ML ops. Those are things that I mentioned earlier. Those things are important in coming up with a product that uses your business problem as framed as a data problem, and then that allows us to take us to a business solution, right? So this is one thing that I want to emphasize once again. We can be excited about technology, but that in itself does not solve any problem unless we frame it in the context of a business problem, right? So I want to move on to a few use cases and a few stories, really, right, from my AI journey, right? And I mentioned earlier that I've worked in multiple domains, primarily manufacturing earlier, and subsequently I worked in the energy sector on a few use cases which are AI specific. And these days I work in the technology sector, specifically on HR tech. So I'm going to share a couple of stories from there. So do you think, Prasanna, can we go ahead with this section? Do you
Yes,
want to?
yes. No, we
All
could.
right. All right. Okay. So I think the first story that I want to talk about is from a few years ago, probably about 5 years ago now. This solution actually won an award at the CNBC Microsoft AI for All event that happened in Mumbai. And the reason I said that it won an award is because it's a very impactful story. And that impactful story was also found to be deserving of that award by that panel, right? And this story is a lesson in using AI to maximize business impact. So I want us to internalize those words, right? Maximize business impact, right? So what I've said here is the client that we spoke to, for who we built the solution eventually, they originally wanted a chatbot, right? So this was in 2018. We didn't have ChatGPT back then. We didn't have any GPT model. OpenAI was a non-profit organization which was getting $1 billion from Elon Musk every year. They hadn't started building anything of value. This was when chatbots used to be programmed with rules, right? So the client wanted a chatbot. So they came up to us and said, our employees should be able to log in, ask for their payslip, and they get their payslip as a PDF emailed to them or in the chat itself. That was the use case that we got from them. So what did I do? I actually went and met the CTO, the Chief Technology Officer, and the Chief Information Officer, the CIO. The CIO's name is Surya Narayana. So I went and met him, and we decided to have a workshop, right? So in the conversation, it came out to me that the chatbot was not the full story of what they wanted, right? So I wanted to find out what other opportunities were there to really help this company with AI. That was my mission at that point in time, right? So then I said, let's do a workshop. Let's actually explore. Let's bring all of your team members. And we did a couple of days of a workshop with like a brainstorming session. And it turns out that we had people from the entire. So we had manufacturing engineers, we had factory assemblers, we had supply chain professionals, we had HR team members, we had design engineers, we had sales and marketing. So we had all of them in the same room, and we were all having superb discussions for a couple of days, right? And then as part of that workshop, I had a chance to go and see their shop floor, right? So I said, how do you guys build solar panels? Because this is a company that was actually manufacturing solar panels, and they have a plant here in Bangalore. So the interesting thing is, when I went to their shop floor, I found some three people standing around one big equipment, and one big sort of machine, and looking into the machine, looking into a visor, and then writing something down, right? So I found three such people doing that, and I had a chance to observe them and speak to them for about 1 hour or 2 hours. And in that process, what I found out is that every one of the solar panels that gets manufactured, so there's multiple cells which get assembled into a panel. Panel gets laminated, and then it goes to a quality inspection step. So these three people who are standing around the machine, they were doing quality inspection, right? So they were doing quality inspection, and the amount of time that they spent.
Rajesh, sorry to interrupt. Maybe you could just show them that screen. That will make it a little more visual.
Right. So I was talking about the process that we use to get to the idea. But yeah, I'll show you the actual problem statement, right? So what was going on as part of the workshop was, I had a chance to actually see the shop floor, and the shop floor quality inspection process really showed us that there's a lot of opportunity here, because there were three people at any given point in time standing in front of that machine, looking at these images and manually pushing the button to say this is a good panel or a bad panel. Because in all these solar panels, there's a possibility of getting different kinds of defects. When you manufacture it, you can get a crystal defect, you can get an alignment defect, you can get other kinds of defects, you can get a crack, you can get a different other kind of defect. So in a nutshell, we thought that this is a great idea for using data and AI to solve the problem. And why is that? Because when an image is captured, and when you need to check specific things in the image, that becomes a computer vision problem statement, right? So now all of you have seen how with a self-driving car, I capture an image, and then I'm able to do specific things in that image, like detect a car or detect a person. Now I can do similar things with a solar panel, right? With an image of a solar panel, I can say, look, this particular cell is misaligned. This particular cell is dark, meaning that it's not got the right crystalline structure. This one is, it has a big scratch, etc. Right? So that's what this person was doing, and these people have years of experience just doing this, and their expertise is probably better used elsewhere. They could be product engineers, or they could be doing other things on the shop floor, but instead they were tediously going through and checking every single one of those cells in every panel. So 72 times. This process took around 10 minutes, and then they had to make sure that the panel was stacked. Good panels were stacked in one pile, bad panels were stacked in another pile. Now, what did we do, right? What we built for them was, we built an AI model. It's what's called a convolutional neural network. And what that convolutional neural network did was to take these images and process them in a specific way, and then classify the image as being a good panel or a bad panel, right? And we went one step further after that. We did an initial proof of concept, which lasted a month. But after the proof of concept was done, we actually had to take this thing to production. So in the production version, they had other requirements. The CIO came up and said, no, I want to know exactly what kind of defect is there in the panel. And I want this to be production scale. So the robot that's going to pick and place these panels, which was operating manually right now, based on a button that the operator would push, the quality checker would push, that had to be, changed so that it's completely automated. Now that's what you see with a convolutional neural network. You can actually make a prediction that, in this case, I've given a toy example of something that looks at an image of an animal and says what kind of animal it is. But what we're actually doing here is using that same kind of a network, training it on this data, training it on the solar panel data, and saying, look, this is an example of a good panel, this is a bad panel. So we had to actually label all the images. We had to put those labeled images into a training data set, train our network, train our convolutional neural network, and productionize that application. So this productionization involved building of an API, building of a REST API. You might have heard the term REST API earlier in the call, right? So it's a way of saying that this is an application which runs on the cloud, and I can speak to that application in real time as the panel's image is being captured, and I get a response back from that application saying, yes, this is a good panel, or no, this is a bad panel and the defect is here. So as you can tell, this is not only classification, but also localization, because I'm able to localize where a particular defect is occurring, right? So now this process of finding and fixing, or to find defects, I should say not fix defects, but that process to find defects took less than 10 seconds as opposed to 10 minutes earlier. So this is the earlier, this is the before state, where it was taking 10 minutes per panel because people would evaluate it. Some people would be good at finding certain defects, others would not be good at finding them, etc. So there would be 3 people over there in the station. Now it's an AI model that's doing everything, and it automatically sends a signal to the pick and place robot, which picks up the panel and places it in, the good pile or the bad pile. So these people saved a huge amount of time and cost as a result of this application, right? So this was an example of a use case where, when you get into AI innovation, right? And this is a message to every one of you. When you get into AI innovation, you're not going to deal only with the good parts. Right? If you're great at building models, or if you're great at writing APIs, you're not going to deal only with that. You're going to deal with the entire range of problem statements, from speaking to your stakeholder, understanding their problem statement, to collecting the data, putting the data together in a place, right? And all that requires empathy, right? It requires you to empathize what the different kinds of problems that different stakeholders face are. So to come up with any inventive solution or innovative solution using AI, before you do prototyping, before you start building solutions, empathize, understand the business area, understand the people, what their challenges are, what their motivations are, right? And the return on investment in this particular case was 20 to 40x. But that opportunity, remember what I said earlier, this company wanted a chatbot, right? So if we had built a chatbot for them, they would have been happy, right? But we decided to do a workshop. We decided to explore their problem statement. A chatbot is not the main job of a solar manufacturing company, right? The main job of a solar manufacturing company is building good quality solar panels and shipping those panels to end users or customers. So the solution that we gave was aligned with that core objective of that company, which is why this is an impactful solution, right? So we were able to empathize and prototype the right kind of solution for this company, right? So as a broader point, right, I want to talk about computer vision and manufacturing because I'm associated with this area. Computer vision is a very powerful capability, not only for the use case I talked about, but other use cases as well. There could be completely different use case for computer vision within the manufacturing sector, but also in other sectors, right? So I would urge you all to understand computer vision because it's one of the key areas within AI right now, along with natural language processing. Another big takeaway from this project is we didn't build any of our models completely from scratch. We used the models that were there off the shelf and made modifications to them. And this is a very important thing to remember. You don't have to be the 100x data scientist who comes up with the model architecture, the training data, tunes everything. That's not possible in today's world, right? What is possible is to use train models that are already good at certain tasks, and there are benchmarks to find out which tasks they're good at. You can use those models and train them on your data and come up with extremely good results, right? Good enough to be taken seriously. So if you're an AI innovator, try to use the freely available AI models as far as possible for your initial prototypes. You can always modify them later on, right? Another big point I want to bring out here is data is the fuel for AI, right? Without getting the data right, you're not going to get very good results from AI. So my humble request is ask questions about the data, try to understand your data, get into the weeds of your data and analyze it. Try to understand how the data quality actually looks like, because that's a big determinant in how big your upside is. There's return on investment of 20 to 40x. a lot of people won't even accept anything less than that because the model already has to be at a certain level of performance, right? So when you start getting the data right, the AI model's performance will go up that much more, right? So these are some takeaways. Now, any questions about the use case that we saw here? Do anybody has any follow-up questions based on what I've shared? And I've shared a complete business use case starting from interactions with the stakeholder or the company all the way to the solution that we implemented. So this gives you the full picture end to end.
There's no scene.
Excuse me, sir.
Sri Lakshmi, I couldn't hear you clearly there.
Yes, sir. I am curious about the software development pipeline of AI models.
Right. So I'll give you a specific example for this particular solution. So on this occasion, we had to use some kind of a data store, some storage area for our data. We called it a data lake in this case, but it could be just a database. We pick up our images from there. We have an application that's running on some kind of a cloud server, right? It could be, these days it's common to use something like Kubernetes, but it's equally possible to just run it on some kind of a virtual machine, right, on the cloud. So that's another component of this. And another component of this is the API. So the API has to be served so that we can, connect to the application from our shop floor and receive those inferences. We can send an image, we can receive a response back from the model, etc. Right? So I hope that answers the question. So that's a very simple description of the architecture. I don't want to get into technical details of the architecture because this is a very high level discussion about AI in general. So I hope that's still useful. Anybody else has any questions?
So Rajesh, I'm just doing a time check. We have only about 30 minutes to wrap the call up.
Right.
So maybe we can skip the second example because we've
Absolutely,
covered
yeah.
a lot of ground in the first
We've covered a
one.
lot of ground. Yeah.
Yeah, and then go to, AI opens out.
Excellent. Yeah, sure. That makes a lot of sense, Prasanna. So I'll hand it back to you at this stage because this is the final slide I have before we get into the second use case. So if anybody wants to know in 5 seconds what the second use case is, it's about using what's called GitHub Copilot. So have any of you heard of GitHub Copilot? Are all of you familiar with it? Okay, so Meera has heard of it. There may be other team members here who have heard of it. Or other people on this call who heard of it. So it's great to know that some of you know about this. Please check out GitHub Copilot. I urge you to check it out. It's a fantastic application. It's great for builders who want to speedily build things, right? All right. So with that said, thank you very much, Prasanna, and for everybody for the great interactions. It was a total pleasure presenting this session. I want to hand it back to Prasanna for the next part of this presentation, which has the ideation workshop portion of this.
Sure. Thanks, Rajesh, but your job is not over yet because you're going to talk about possibilities, right? So
absolutely, yeah. No, I'm still here on the call. Just for everybody's context, that's the next portion of the call that's going to happen.
Right. Okay. So I'm just going to share the screen from my end. Hold on. I'm just going to rush through these screens. Okay, so Rajesh, do you want to kind of, just from the point of view of problem scoping, Rajesh and I were discussing about problems that each of us would love to solve, right? So Rajesh, do you want to take a quick, stab at what you see on the slide here? Yeah,
absolutely. So there's 4 problem statements that are listed out here on this slide, right? So I'll talk about and I want to start with the second one because we we kind of went in that direction in one of the earlier discussions that we had.
Yeah.
What if I were to write a script? Let's say I'm a script writer in a movie production house, and I write a script, and that script itself could be used to generate a movie directly. Right? We already have the ability to take text and generate images from it. Now it's one more step to take a piece of text and generate audio from it. We have the ability to take text and generate video from it. That's also possible these days. So why wouldn't it be a stretch to take text like a script and generate a movie from it? So that's a very interesting use case. That's a multimodal generative model where we write a script, like maybe you're writing the next big blockbuster script, and then the images and video for that, along with the audio, get generated completely using AI, or at least partially using AI. So it's a fantastic use case, I thought, and it's kind of very similar to what we were discussing earlier on tracking emotions and content and stuff like that.
And
So the
just
first,
to,
yeah.
sorry, just a quick interruption. So just to kind of add to what Rajesh was saying, if all of you guys, want to look up a movie called Morgan on YouTube, and maybe even just type Morgan and IBM. Years ago, the research team in Israel and IBM were focused on this problem of how do you enable AI to detect emotions and deal with emotions, right? So Morgan, the movie, the trailer of the movie was made entirely using AI. So you guys can Google or YouTube, more details on this, but it's basically a very, very exciting space. And there's a lot of work that's already being done in that space. Rajesh?
Yeah, that's a great segue. I think another thing I want to call out here is number 3. What if we didn't need terabytes of data to train AI models? The big AI powers these days, the sort of benefit that they have is the huge amount of money they can spend on compute power. For a
Yes.
country like India, and for small, entrepreneurs, for small scale innovators to compete in this space, there is some very exciting work coming out of a company called Databricks. Databricks does a lot of work in the data engineering space, and there are other companies also doing similar work. But what they're trying to do is, can I build high quality data sets and train models with them? And can I get as good performance, if not better, compared to OpenAI or other big companies that have huge amounts of money to throw at compute, and they use that money to train a model on huge data sets, right? So that's a very interesting problem. Those of you who are a little more technical can look into that problem statement. Another area that I want to go to is what if we could make a digital copy that's authentic to a physical system? We all come across cars. We all come across automobiles, trains, planes of different kinds. All of these are manufactured systems. They are physical systems. Those physical systems have different characteristics. They have behavior, and it's possible to model all those behavior using algorithms. We can collect data about those physical systems and create digital models of them. Now, how do we take this to the max and completely clone or create a digital twin of a physical system? So this is a very exciting space because it could potentially speed up. It could do to hardware what happened to software. Software is so easy to automate and produce and test and everything. Hardware is not so easy to ideate and design and to produce. But with a digital twin of some systems, we can evolve digital twins and build very cool systems like that. That's another idea. So those of you who are into manufacturing, advanced digital manufacturing, could look at that. And finally, what if we didn't need to teach models how to learn from data or what data to learn from? So this is like the maximalist use case for AI. What I mean by that is, assume that AI can give you great benefits and expose it to as much data as you can give it. Give it as much of the fuel. I said earlier that data is the fuel of AI. What if you could expose as much data as possible to AI and build the algorithm in such a way that it can learn, it can figure out what to learn from, and it can figure out how to learn. It designs its own network, it designs its own architecture, and it is able to choose its own data set and learn. What would it learn then? That's a very interesting line of exploration, which could give us advanced AI capabilities. There's already work being done on automated reinforcement learning. So these are the four problems that I would love to solve. You can see that they combine applications as well as techniques, right? So that's what I want to point out again. AI is about not only techniques, but also applications. So there are two things here that talk about applications, there are two things that talk about techniques. So hopefully this is useful impetus for some of us who are thinking about AI products and innovating in this space. Right? So back to you, Prasanna.
Yeah. Yeah, and what's interesting to me is that, the problem that I'm wrestling with right now is, how do we enable, young minds, right, to learn how to learn, so not really, be bothered about guidance and paths, but and about what they should learn, but learn how to learn. So we're kind of, I think, going, machine and human, almost kind of going parallelly in that context. And that actually opens up the other perspective that we just wanted to lay on the table for you guys. And we will leave it to you to explore that the problems and which convert themselves into opportunities exist in almost every domain, that you can think of, right? So you see some of them captured here. Autonomous vehicles, we have spoken about a great deal. Personalization, we have spoken about. Personalization in the medical space is also, a very, very hot area, and there's so many possibilities there. Sustainability and climate change is another area. My pet peeve is about, or the problem that I consider, to be very interesting for me is AI assisted creativity. So I'm, looking at how do you, enable creativity? How do you measure creativity? Because that's again a very, very subjective space. So that's an area that I'm personally very aligned with and very into. And then you have other areas. Education is a very big space where AI could make a huge, huge dent. It could enable all of us to move from just information absorbers to, to those that apply information. It could take us to the next level. It could, enable us to learn how to learn, right? So these are all some of the opportunities that are there, and these are all areas. I don't know if I mean, several of you are applying for the Young Innovators program, but these are all areas. If you are, these are all areas from where you can build problem statements, pick up problems, and then expand them into ideas that you may want to submit. So if you have ideas, then please do reach out to us. But before you do reach out to us, what I really wanted to do was, to give you a bit more of an insight into how, you take the next step in your path to pitching your idea, or to crystallizing your idea. So I'm an entrepreneur myself. I quit my job in IBM and said, hey, I want to go down this path again, because it's on my bucket list. And, I didn't want to, I wanted to enjoy. One thing that I'm learning, despite all my years of experience, is that, it's really not about technology. It's really not about the solution. It's about finding the right problem. It's about articulating the problem. It's about ensuring that you've gotten the problem right. A lot of us, when we talk about, our ideas, and we talk about for potential businesses, we go directly to the solution. Sometimes we go directly to the technology, and that's where that's the issue with most of these startups in our large startup community right now, and that's one of the key reasons why startups fail. So one thing that I want you to remember, and I'll give you a small little framework aligned to that, is It's all about right. Once you do that, then the rest of the things fall in place. And how do you define, a problem right? So I'm just kind of giving you a very, very high level example here. There's a lot that you can Google and learn about this area. I've put down the URL of the site from which I've picked up this example because it's a fabulous way of explaining the importance of a problem statement. But you just look at the first iteration of the problem statement of this is a real company, right? So this company says people have a huge problem with traffic in Sao Paulo. They are going to build the leading ride-sharing app for them. Now, this is a good, way of defining your problem to begin with. But the issue with this particular statement is that, it's just, the first half just talks about huge problem with traffic. So you're kind of alluding to a problem. But the second half has already gone into a solution. It's already talking about a ride-sharing app without really understanding other nuances of the problem. Now, what are the other nuances of the problem? The first step in that context is to go back to your customer. Who are you solving? Who has this problem to begin with, right? So here they say people in Sao Paulo. Now that's a very, very broad description. You'll have to actually narrow down that description. And now as an entrepreneur, one thing I've learned is 90% of those that I consider are my customer group, may think of my solution as a nice to have. And I'm going to ignore them. I'm going to focus on the solution is a savior who has this pain point, this huge, huge pain point, right? So in their case, what they have done is they've really gone back, looked at the customer, and they've said, okay, out of all the customers of all the people in Sao Paulo, we're going to focus on young men aged 25 to 35 with middle to low income who live in suburban Sao Paulo and work in a corporate office in the city center, because those are the people that, face the pain point of traffic, right? And they also face the pain point of not having a lot of money to resolve that place where you begin. And then you go on to context, because the context is what triggers the customer, right? So you then, so here you see it's a very beautiful way of representing the context where you say, when does the customer face this pain point? He or she faces this pain point every workday in the mornings and evenings for an average of 2 to 3 hours per day. Okay, so you've figured out the customer, you've set the context. Now you do what you call a root cause analysis, right? And what we mean by the root cause analysis is at a high level, you say, hey, there's a problem with traffic. Okay. Now, is that actually, the way you define the problem? Not really, because that's a symptom of the problem, right? So what is the real problem? What is the key pain point that has to be addressed? That's what root cause analysis helps us in figuring out. And I've given you an example of how you do root cause analysis. Say, why is, traffic a huge problem? Because it takes a long time for people to get to work. Okay, so what? Why is that important? It's important because they're wasting precious time. Okay, so what? Why is that important? Because they might use the time to do something more valuable. Again, what is that definition of the value? Because they could earn more money in that time. The time that they're wasting is actually money for them. And that is where, the pain point becomes significant. So that is the reason, and that's how you do a root cause analysis. Keep asking yourself the why question, so that you move from the so-called symptoms, which is, the huge problem with traffic, and get down to the actual pain point. So if you see the final problem, the way it's stated is lose time in traffic instead of doing something more valuable. So the words more valuable becomes very critical. And then you look at it from the point of view of the emotions that are attached to this problem in your end customers. Okay, because emotions are extremely important in them deciding to make a shift to your available currently and what we are doing currently. So in this particular case, the alternates that they had was, they could wait for the bus or whatever, or they could sign up for Uber. Now, we went a step deeper, and they figured out what are the shortcomings of, the alternative Uber. They found out that, with Uber, it's very difficult to synchronize time for these people for whom money is very important. So that gives a competitive advantage. That gave this group a competitive advantage, and they were able to quantify, the impact very clearly. They said 40 hours per month is lost at a minimum, and that 40 hours translates to $3,000, right? For each of these users, and therefore that's significant enough a problem for us to action on it. Now, the reason for going from your first iteration to your final iteration of the problem statement is the way you design your solution changes totally, because you then realize that maybe what I started off with in terms of an app really need not be some kind of an app like Uber. I need to create some kind of a timeshare that's very local, that may be subscription based, and that's exactly what these folks did. So it's very, very essential for you to define your problem in detail and to the right level for you to then get to the ideal solution for yourself. So that's something I want to underline for you. And that's where we have a small little, I call it a pitchathon, that we would want you to participate in. So it's a 3-minute video pitch of a problem statement that you're working on. And I'm assuming that all of you are interested in either going into the the Young Innovators program and submitting for it, or you have your own ideas in terms of the kind of startup that you want to build or the business that you want to build. So do a 3-minute video pitch of the problem statement after going through the exercise that I shared with you, right? You can do it in any which way you want. You can have slides and do a voiceover, or you can just sit in front of your phone and just talk. But the bottom line is you should be able to get to the crux of the problem, and articulate that particular problem in the way you believe you see it, and align it with your solution from the point of view of the value that your solution can bring in. But you can do a problem and solution view, but we basically want to see how you articulate your problem statement and help you on that front. So once you do your 3-minute video, please upload your videos onto this Google Drive. It's as simple as that. And we're giving you a week to complete this. And the reason why this will be valuable for you is because we will have experts at our end, experts like Rajesh and a few others, who have built companies of their own, who are investors, who are angels, who are techies, who are business, leaders. They will be looking at your submissions, and they will pick out, say, 10 problem statements that are most promising. So if you getting validation, and I understand that as an entrepreneur today, getting validation from from others in the community and those that are more experienced is very, very very, very valuable and very important from the point of view of growth. So this is what we are looking forward to you guys doing. A 3-minute video pitch, submit on Google Drive and submit by the 15th of June. Okay. And we will give you the results by the 22nd. So I'm going to pause with that and check with you guys if you have any questions. I'm sorry, I just ran through it a bit because I'm very mindful of your Sunday afternoon, and lunchtime. So I'm going to pause now. Any questions, any comments?
Prasanna, this is Rajesh. If I may add something.
Sure.
So I think what Prasanna brought out in the earlier slide, as well as the instructions here, right? Some of the things she said are super important. I'm a person who's been in a couple of startups. I've been in the entrepreneurial journey, and I have seen what it looks like for other people, for say a founder, to take on risk. It's crucially important to frame the problem statement very well. It's also a very, very good time to be innovating and to be working at the intersection of business, AI, and innovation. So my humble request is, if you're on the call, but you don't know if your idea is good enough, don't worry about that. Go for it. Have a gung-ho attitude. Submit your idea. Prepare the 3-minute video and send it to us. Both Prasanna and I'll be happy to take a look at your idea. I think it should not be, you should not self-limit yourself, especially when it comes to innovation. Please go for it, and whatever problem statement you have, express your idea through this kind of a, frame it through this kind of an approach, and you'll be able to condense it to a very good 3-minute short discussion, right? And
Yep.
I'm really looking forward to seeing many of the names here in the list of videos that we received. So that's one thing that I wanted to add.
Yeah, and I think, I don't know if Thomas from MuLearn is on the call, but I'm also hoping that the recording of this session goes out to the larger community, so that they can also benefit from, what we are offering.
Definitely, Prasanna. We'll be sharing the recording and information, if possible, with all the people in our community, and we'll also be sharing this task as well. So people are interested can definitely submit their problem statements as well.
Yeah, and let me just let you guys know, just adding to what Rajesh has said, even those with years of startup experience and years of corporate experience find it very difficult to put together, to get to the right problem state, right? So, but the bottom line there is to be bold and, not to worry about, getting anything perfect, right? So it's about iteration. It's about, it's about being agile. So that's what, we will recommend to you. Any comments? Any questions for Rajesh and me? It can be any question. It can be about problem statements, or it can be about technology. I think we have about 5 minutes more. Okay. If not, then let me just stop sharing my screen. And I think, we can wrap up this session now, Thomas. We had
Definitely.
a fabulous session, I must say.
Yeah.
It was a wonderful interactive session. And I hope that you guys, have learned something valuable from this interaction.
Thank you so much, Prasanna, and thank you, Rajesh. The session was actually incredible, one of the best I've been to personally. I was actually listening to the entire session, taking down points, and I might probably submit my own problem statement. So yeah,
Looking forward to it, Thomas.
yeah. So I can't thank you enough for the time you spent here with us. So I'm really happy to have you as part of MuLearn and as part of this initiative. Thank you once again. So thank you to all the participants who've joined as well. So we'll be sharing the resources, that is the recording, and if possible, a short summary of what was discussed today, along with the link where you can submit your problem statements. If you have any queries, you can always reach out to us via the community, and we'll be more than happy to resolve it. So looking forward to seeing all your submissions, and thank you once again to Rajesh and Prasanna for your time.
Sure.
Really appreciate
Thank you
this. Thank
so
you.
much. Yeah.
Bye. Good luck, everybody.
Bye.
Yeah.
Good luck.
Bye, everyone.